Michael Bolton, thank you so much for being here.
No, thank you for having me. I love talking about testing, and I anticipate that's what we're going to do.
Yes, indeed, we're going to talk about testing. Today, it's going to be a bit different than other episodes I've done because with us as well is Diego Castro, quality lead at Xseed. And, he has more than 7 years of experience doing testing and automation. But I mean, we got the expert, right? We got the Gandalf of QA, Mr. Michael Bolton, 25 years of experience in testing, founder and leader at developsense, a consulting firm in testing and everything QA related, where he teaches everyone about rapid software testing, both a skill and a mindset, a way of thinking and managing yourself in the quality world. And an interesting fact, Michael visited Uruguay back in 2017. That's where Diego met Michael, and Diego basically, when we were getting ready for the podcast and Diego was going to ask you, Michael, he was like, I want to bring Michael. He's like the best person out there, the best expert, his mind, the way that it works, the way that he talks about quality, so much passion, so much knowledge, and we are very glad that you accepted to be here, Michael. With that said, this is going to be a bit different because I'm going to do less of talking and less questions, and I'm just going to admire two great professionals talking about QA, testing, technology, how the landscape is changing or not, and some other interesting stuff. Diego, over to you.
Thank you, Mateo, and thank you, Michael, for being part in this episode of the podcast. So I would like to start talking about your beginnings compared to mine. For example, I have, as Mateo said, I have over 7 years of experience as a tester, and I've seen the role of the tester change quite a bit. Technically, the task we do every day, and considering you have over 25 years of experience, what was it like when you first started? Why did you start as a tester, and what were companies looking for to hire new testers?
Well, if we're talking about getting started, the first thing I'd like to start with is a thank you to Mateo for that very gracious introduction. That was very nicely done. Thank you. All right. How did I get started? Boy, there's so many different ways to start. I could say that I started testing 62 years ago when I was born, because that's how humans come into the world. We're all testers. That's how we learn. We try things, and we learn from the experience. On a more sort of practical level, I started testing software for money when I became a developer, a programmer. I was working in an HR firm that needed some code written. And so part of developing code responsibly is to try it and to look for problems in it. And for some of us, that's a very natural state of being, not just to look at how things work, but to look for problems in them too. Remembering George Carlin's joke that some people say the glass is half full and some people say the glass is half empty. I always want to say that, well, maybe the glass is too big. So, but I started testing software when I started developing software. I then went to a company where I was a tech support person for a bit, but I was seconded to the newly created at that time testing department to do testing work and to coordinate some of the work of other testers, because we had a great big hairy project that had lots of different components in it and lots of different possibilities for problems. And the testers who worked at that company were finding lots of problems. And so I became the kind of a bug czar performing testing and looking for relationships between the problems that we were seeing so that the developers could make the most effective use of that awareness and knowledge of what the product was up to. So that was, oh my God, that was 30 years ago now, that role. It's interesting when you asked the question, Diego, you said the role of the tester has changed. I'm not so convinced that the role of the tester has changed that much. The tasks have changed to some degree, but I think that a big mess up we've currently got these days in the testing business is that the fundamental role of the tester, which is to examine the product, to explore risk, that role stays consistent. But a lot of the tasks within that role seem to have been diverted away from actual engagement with products and have turned into a kind of a role in which we try to persuade other people what a great idea it might be to test something. And I'm not convinced that that sticks that well, because the people that we're talking to on that level are people who have a different bent, a different mindset. The mindset that they have is oriented towards creating things, towards building things. And to some degree, when you're in that frame of thinking and that frame of work, you are to some degree suppressing worries about the possibility of failure. To be a developer, to be a designer, to be a manager is a fundamentally optimistic kind of thing. We're focused on trying to get something done, trying to get something built. And when I'm working on my own code, that's the mindset I'm into. It really, really helps me a lot when someone else looks at that product that I've built and does so with the intention of looking for problems. That's really different because I'm not exactly doing that. I'm looking for ways to make problems go away. I'm less oriented towards finding problems that I might have ignored along the way, that I might not have noticed along the way, or that I might have introduced along the way. And so that fundamental perspective that testers have, should have, in my opinion, that hasn't changed. The nuts and bolts of performing tests, that has changed to some degree, although, again, not as much as I would hope. The deal is that as you're building something, you want to check it, examine the output, examine in little tiny experiments the product that you've got, so that you can decide whether you're reasonably close to what you intended to do. That's normal for a developer. And if we're looking at designs, or if we're looking at artifacts of some kind, requirements documents, even ideas about the product, it's normal to look at stuff from the perspective of what a great job we're doing so far. The tester's role is to look at whatever we've got in front of us and not to try to make people's troubles go away, but to find trouble wherever we look. What I worry about a little bit is that talk about testing and thinking about testing has been dominated by that kind of mindset wherein we're just checking to confirm that what we've done seems to be reasonably okay, rather than looking for deep, rare, hidden, subtle, intermittent, emergent problems with the thing that we're building. And that requires a shift from the builder's point of view.
Got it. So considering that the tasks have changed. Which tasks do testers from today don't do that testers when you started did every day?
Well, I started at a Silicon Valley-like kind of company. It wasn't in Silicon Valley, but it was of that ethos. It was a mass market commercial software product that allowed you to do this incredible thing. Such a weird idea. I don't know if it ever has gone anywhere since then. It was called multitasking. It allowed you to run multiple programs on the same machine at the same time. It's crazy, really, when you think about it, how anybody could think that that would be a good idea. But there you go. We were creating a product that allowed you to run any product you like at the same time, virtually at the same time. It was stuff. We didn't have parallel processors at that point, and we didn't have multiple core stuff. But by switching very rapidly from one program to the next, we could create the illusion of multitasking, which is pretty similar still to what's actually going on. But our promise, our unique selling proposition for this product was that you could run any DOS program, DOS being designed as a single tasking operating system. You could run any DOS program and multitask it with any other DOS program. And in order to do that really well, of course, in order to test that well, we had to test literally hundreds of products running inside our product. So we had this really interesting approach, which seems to have escaped a lot of people these days, which was to use the damn stuff, to interact with it, to exercise the functions in each product that was running under our product, and look for problems associated with compatibility between those products and our products to see if those products would cause our product to stumble. Our product was called Desk View, so I'll refer to that. We were looking for anything that would threaten the value of Desk View or that would threaten the value of the products running under Desk View. And so that involved performing a lot of experiments really quickly to find those kinds of problems. We also had a product that sold even better than Desk View. At the time was a memory management product, which had similar kinds of considerations. The processor was built to hand out memory in a variety of ways. And our product provided a bunch of software interfaces to get at that memory. And there a bunch of interfaces had arisen along the way. So we had to do experiments with lots of different kinds of software that was asking for memory in different chunks and different sizes in different ways using different software interfaces and so on. So our testers were continuously using the products, interacting with them, exploring and investigating, being there on the scene as we interacted with the product and performing experiments. It seems to me that what passes for testing these days amounts to a fairly elaborate set of processes to make sure that nobody sets eyes or hands on the product. And I find that really frustrating because in my daily experience, I set eyes and hands on products all the time, and they show signs of not ever having been looked at by any person. I can't look at a product and imagine a project manager saying, Why, yes, that's exactly the way we wanted it to behave. I mean, it just it's crazy. I was testing a chatbot last night with James. We were testing a chatbot, and we asked the chatbot about services that the company in question supplies, products and solutions that are easily visible on its website. So we asked the chatbot some questions about those things. And in the majority of cases, not just one or two cases, in the majority of cases, something that was referred to on the website, the chatbot said, well, we don't do anything like that. We don't have a product like that. I mean, I was gobsmacked. How would anyone release that chatbot in that state and think, hey, this is going to be great, unless they hadn't looked at it? I'm words failed me at the time, right? I couldn't believe it, but that's what I think is happening with testing of AI products, for example, large language models. A lot of what's going on in academia, and I bet a lot of what's going on in commerce, is they run it by a statistical modeling system. They don't actually try to use the dang thing. That's why the jailbreakers and the people who are asking chatbots for things are so successful, because nobody did that before. And what they're revealing pretty quickly is that this stuff is fundamentally unstable and unreliable, prone to hallucination, prone to incorrectness. And that's going to get, I fear that's going to get a lot worse, because the road to solving those problems is not at all clear at the moment.
Yeah, it's crazy. I heard people suggesting to test AI with AI, and people seem to like that approach.
It's like testing, how do you make sure the elephant isn't gobbling up all your peanuts? Well, put another elephant in there. I don't understand people's line of thinking. Having been a program manager as well, I just don't understand the program management mindset that allows that to go on.
Yeah, it's crazy about people. So I'm glad you threw AI on the table. So let's talk something pretty about AI. What was the first time you saw an outcome that felt like magic? Like, how can a computer do this?
Oh, geez, from the earliest days. I mean, one of the reasons that we're hearing so much about AI these days is that the world got tired of talking about software. And now we talk about AI. Well, any sufficiently advanced technology, as Arthur C. Clarke said way, way back, literally generations ago, any sufficiently advanced technology is indistinguishable from magic. And you can't spell magic without AI. Of course, you can't spell failure without AI either. But I mean, when I first started looking at software at all, it made me wonder, wow, how can a machine do that? I mean, the kind of miraculous looking stuff that you could see on I had an Atari 800, for example. I was one of the weird guys. I didn't have a Commodore 64 or an Apple II. No, I had the when you're number 3, you try harder kind of machine. But any marvelous output from a machine can look like, if we drop our capacity for critical thinking a little bit, it can look like there's an intelligence inside the machine. We anthropomorphize this stuff because we're not used to seeing ordinary machinery do stuff that we can't in our minds understand. Somewhere in the back of my mind, I can figure out how a car works. It's obvious how a bicycle works. It's not too hard to figure out how what other kind of machinery do we have in our daily life? I've got a fan here that helps keep me cool in the summertime. It's not too hard to figure out how that works. It's not sensing and deciding and acting. But as soon as you've got something that takes information from the outside world and changes its behavior and presents that behavior to somebody else, sense and decide and act, those are the sort of germs of what we might consider to be something that's in some sense intelligent. Okay. So then we've got software that was written by people consciously, intentionally. But if you don't know how it works, it looks like it's intelligent or super smart. My favorite example of that, I guess, was when my wife first showed me a program called Shazam. It's a little thing in your iPhone, and you can hold it up to a speaker in the restaurant when you want to hear a song, you want to know, hey, what's the name of that song? And it goes through a vast library of stuff, and it performs fast Fourier transforms, probably in order to detect the waveform, and matches that up to a fragment. I have no idea how they do that on any kind of basis other than, very, very broad principles. There's some fancy math in there. But it's easy for us to say, wow, that's artificial intelligence. Now, it wasn't branded that way a few years ago, but I can guarantee if Shazam came out today using exactly the same algorithms, they would say, well, it's artificial intelligence. Because it's a marketing term, and it's been a marketing term for a long time. So machinery that makes decisions, senses and decides and acts without us understanding the particular algorithms which are in use at the moment, that can be cast as AI. And sometimes that's actually true. Sometimes they're machine learning algorithms that try a whole bunch of algorithms. It's like boiling, hundreds of pots of spaghetti and throwing the spaghetti against the wall. And we just take the spaghetti that sticks best from, so that's the recipe we use, the same, the same temperature of the water and the amount of salt and the same quantity of spaghetti relative to the water. Okay, that's the perfect match. That is our spaghetti recipe. And the machine chooses it for us because we say, we like that one. But the machine varied all the different parameters and so on that you might consider going into a pot of spaghetti. And it chose that one. And we don't know why it chose it. But for some purposes, but that's okay. We don't need to know why it chose it. What we do need to do, though, is we need to be conscious of the fact that anytime we have a different kind of spaghetti or a different composition of salt, or if there's minerals in the water that are going to change things, or if the timing is off by just a little bit, the spaghetti is going to stick in different ways. So there's something vaguely creepy about that. There's something worrisome about that for me as a tester, and that is if I don't know how the code works, or if nobody knows how the code works, we also don't know how to fix it. That should be something fairly alarming to anybody who's in a position of responsibility for this stuff. Because if we don't know how to fix it, that's bad. But there's another problem, which is that if we don't try lots and lots and lots of different circumstances that could change things such that we get an undesirable result, the product is going to fail in ways that surprise us. And those surprises can be very, very unpleasant. And so, I mean, here's a trivial example. It comes up all the time. they're early forays into AI. One of the optimistic things that people thought was, well, this stuff can help radiologists to determine whether a certain image is showing signs of cancer, right? So show the machine learning algorithm a whole bunch of different images and label them appropriately. This one, is associated with cancer. This one isn't. This one is. This one isn't. And the machine learns to classify them. Except there is a catch, or various runs of this. One was that the images themselves had little text along the side that would identify where the image came from. And surprise, surprise, the images that came from cancer hospitals tended to have more salience than for determining whether it's cancer, but the machine learning wasn't looking at the growth, it was looking at the labels. Another instance of it was certain images had rulers associated with them, right? There was a ruler in the image to show the size of the thing that was being looked at. And of course, put a ruler down on something that's not that interesting. And so the machine learning was catching things with rulers in them. And this kind of problem has been around for a long time. There's a really wonderful book a few years ago called You Look Like a Thing and I Love You, which was a catalog and an analysis of various kinds of AI failures by a woman named Janelle Shane, if I remember right. And she found lots of ways in which machine learning algorithms would surprise us in all kinds of interesting ways. One of my favorites was a robot that was designed to get from here to there most efficiently. And they modeled the robot in software. And they said, okay, try to get from here to here in the most efficient way possible. And I think it was designed to be a bipedal robot, right? 2 feet standing up. And of course, its way of getting from here to there most efficiently was to fall down and flip itself over and fall down and flip itself over and fall down and flip itself over, which is not an intuitive result until you've seen it, and then it becomes obvious. So that capacity for surprise, when we let an unsupervised machine come up with ways of solving problems, can be really wonderful, insightful, but it can also fool us into believing that we have a solution to a problem where the machine is solving an entirely different problem from the one we think it's solving.
Yeah, I agree. I remember using ChatGPT since the beginning in November. It's crazy that ChatGPT has been released to the public less than 2 years ago. But I remember I was doing a migration from Java to TypeScript. I was migrating an automation project. And as I didn't know that much of Node.js, at the beginning it felt like magic. But with time, like the algorithm started to do crazy things. And as I started learning TypeScript, I realized that the answers weren't like real answers.
Of course not.
It's crazy. But once you get to know how to do things and you start challenging the AI outcome, it's like it's not that good. Like not all the results they look as they are real, but they're just nonsense.
I urge people to look at Rodney Brooks's essay. It came out very shortly after ChatGPT was launched. It was maybe not an essay, maybe an interview in IEEE Spectrum. And you'll find it on an internet search by looking for "Just Calm Down Already" about ChatGPT. Rodney Brooks, and that'll get you the link pretty quickly. But he's got the line that describes it perfectly to me, which is, large language models are not designed to produce an answer that's right. They're designed to produce an answer that looks good. And for some purposes, something that looks good doesn't have to be right. But most applications in testing and most applications in software, it seems to me, there's a really, really big and important component where the dang thing has to be right. And when it comes to generating code, all of these ridiculous claims that we're not going to need programmers anymore, or we're not going to need testers anymore, we're not going to need designers anymore, because we have a machine that can spit out strings stochastically. Come on, stop it, AI fanboys. This is not going to be a problem that's solved by stochastically generated output. Just cut it out.
But even if it was for a brief period of time, were you concerned that the role of the tester was going to go away and machines were going to test code itself? Because from my perspective, like the first time I asked a simple question and I got code back, I tried the code and the code ran, I was like, okay, I have 6 months for working, and that's it. I'm going to be out of a job pretty soon. Luckily, I don't think the same thing right now. I'm actually way more on your side. But do you think about that for just a while?
I have to say, it has really bugged me how long it has been taking for people to recognize this. How did I come to my rather it started off as skeptical. That's the default stance for a tester. Well, okay, you've made a claim. Are you sure about that? How did I come to be much more jaundiced about it? Because I tried it. I actually tried to do the things that the AI fanboys were saying this is able to do. And with my colleague James Bach, we designed some little experiments. For example, we noticed, it was out in the air that if you got a large language model, ChatGPT or Bing Chat or Copilot or whatever they're calling it this week, if you asked it something and it got it wrong, all you would have to do is ask, "Are you sure?" And it would say, "I apologize for any confusion." And then if you ask, "Are you sure?" again, it would say, "No, I was right the first time. I apologize for any confusion." All you had to do was to do that a few times interactively. Now, then what we did was we decided to do that systematically. We went to the APIs, to OpenAPI's API playground, and we started asking a variety of questions, and then asking, "Are you sure?" after that. And we did hundreds of trials, 150 trials. Now, here's the hard part about testing output from LLMs. If you want to test it thoroughly and diligently, you have to look at the danged output. And the output from 150 experiments is something that warrants some scrutiny. And it takes time to do that. If you don't take the time to do that, then you are almost by definition ignoring any opportunity to see problems that might be rare or hidden or subtle. So we did dozens and dozens of experiments, and basically what we found out, for example, when we would give it a list of stuff in a JSON format or in a text format, and we would say, okay, here's apple, banana, carrot, banana, apple, carrot, banana, banana, banana. And the return in a JSON output the number of instances of each one of these things. And as soon as a list got to any length at all, 20 items or so, the count would start messing up. So, all this stuff about, oh, we can use AI to generate reliable test data. No, you can't. You cannot use it to be, it is designed to be unreliable. It's designed to vary its output. So if you want to generate something reliable, my advice would be write a program to generate something reliable and use our smarts to do that. We can do that much more deterministically. And if we want randomization in there, we can induce randomization, but we can do it deliberately. If you're using a large language model to do it, the randomization is something that's being decided deep in the parameters for the LLM. And so you're going to get unpredictable and undesired results when you use it for that purpose. So that was one. Another was we took somebody's, in two cases, we took somebody's glowing report of how great it could be for a large language model to generate test cases or to generate a test strategy. And it was absurd, absolutely absurd. If you don't look too hard, all you see is this wall of text and you say, wow, it sure produced a lot of stuff. But, there's important distinctions to be made about your pipeline. Your pipeline could be producing pure water, or your pipeline could be a sewer. And what we were seeing was sewage coming out of this stuff. There'd be some water, but there'd also be little lumps of stuff in there that you don't want to see. And so what we would get from people who didn't look too carefully, especially AI fanboys, look how wonderful this is. But that didn't stand up to scrutiny. The trouble is, refuting this stuff takes an order of magnitude more effort than it does to produce it. So one of our early investigations of AI claims involves something that, according to the author, it took 30 minutes for him to do. And it took us 30 hours to decompose it and deconstruct it and identify patterns of failure and identify specifics about where the answer was okay, even good sometimes, but by and large, pretty poor when compared to somebody who is an expert analyst. Now, you could say, but wait, experts are really hard to train, and it takes a long time to learn this stuff. And it's just skilled testers are so hard to find. So wouldn't it be great to get the machinery to do that? Well, you know what else is hard to find? Skilled pilots. And nobody in the airline industry says, it wouldn't be great because pilots are so expensive to train. Wouldn't it be great if we just got rid of all the pilots? Well, okay, go ahead and do that, but I ain't getting on the plane.
Yeah, I think me neither, at least for a while. Maybe, I don't know what's your thought about AI in 10 years, but I'd rather get on a plane with someone real as a pilot.
Look, AI can be really, really helpful as long as humans remain in charge. That's the key to it. But we also have to remember that, like any other form of software, every form of software allows us to do this. It allows us to do stuff faster, at greater volume, at greater depth, at greater extent, software allows us to probe the system. As a tester, we do this all the time. We use software to help us identify things in the output. Lately, we've been having lots of fun probing these massive JSONs that are coming from practically any online system you use these days. We can use software to extend our superpowers as testers. But technology is always agnostic about whether you're doing it in a skilled way or a correct way or an appropriate way. So if we are skilled people, then technology allows us to exercise our skills and to exercise our depth of vision. But if we're not skilled people, any kind of technology allows us to do bad work faster and worse than we've ever done bad work before. And people keep forgetting that. I remember saying that at a testers meetup in 2002 here in Toronto, that this guy was saying, well, no, we can do 10,000 tests in I don't know what his interval was, 10,000 tests in 5 minutes. Well, sure, but are they good tests? If they're not good tests, what's the point? And what happens in our minds a lot of the time is we say, 10,000, that must be good. 10,000 is a lot. But, as I say, a sewer pipe that produces output at incredible volumes is one thing, and a sewer pipe that produces, or a pipe that produces a pure water is an entirely different thing. So we got to be very careful about what the AI is extending, or what the software or the technology of any kind is doing. And with AI, you asked about AI in 10 years. What we see now is for certain things, the first 90% of the work is easy. And what's hard is the last 90%. And no, that was not a mistake. The problem is usually a lot bigger than people realize. And that played out with self-driving cars, how...
I was going to ask exactly that. Would you get on a Tesla, a self-driving Tesla?
I've been in a Tesla, and one of the things that really blew my mind about it, but I could not conceive of this. You know how you're not supposed to be on your cell phone when you're driving?
Yeah.
On Tesla, you've got a huge tablet that you're on while you're driving. All I have to do is to look at the reports that are coming from the field and make a judgment about who's who. When you're dealing with something like a car, and somebody says, this is great, it's safe, it does everything I want, that's very nice. The people you've got to listen to are the ones who say it ran through a stop sign. The ones who say it didn't recognize this thing on the street. It ran over the corner of the curb when when it was supposed to be turning left. It managed to ignore a traffic signal. This is the difference between testers and fanboys. What we want to know about is everything. We want to know about the truth. We want to know about the warts. We want to know about the problems. So when somebody comes along and says, this thing is wonderful, we can say, that's very nice. Now, let's see if there are problems here that are going to bring loss or damage or harm to people. And we do that through experimentation in places that aren't easy. We make the product stand up to a challenging experiment, and we don't hand wave away the problems that we see. That's what it means to be not only a tester, but to be an ethical and responsible engineer. Not a cheerleader and not a fanboy.
Yeah, I agree. Me personally, I won't get on a Tesla self-driving car for a while. I'd rather be one of the last persons in the world to try a self-driving car. But I
we
want
have
to be very
self-driving
sure
cars.
that nothing is going to happen.
We have self-driving cars. We call them trains and taxis, buses. These things are, from my perspective, I'm not doing the driving. I don't care who does the driving, but it's going to be a long time before I trust machinery developed by some dude 6 months ago to make decisions in real time such that it affects people. And here's a great way to prick the bubble of people who are all enthusiastic about this. Are you willing to accept personal responsibility when your full self-driving Tesla happens to kill somebody, are you willing to go through that? And is your insurance company willing to go through that with it and indemnify you from that problem? And the answer so far is no. The insurance company is saying it's your responsibility if that thing screws up. So as I said before with other stuff, I want humans, thinking, conscious, ethical, responsible humans to remain in charge, to override the decisions when an AI is doing something irresponsible. Because humans can accept responsibility, machines can't. If Tesla were willing to say, you know what, anytime full self-driving puts you in a position where you could get a traffic ticket, runs over a kid or an old person, anytime if a Tesla does that, that's on us. That day's not going to come because Elon and his crowd are fundamentally irresponsible people. Fundamentally. And you know this by their behavior.
Yeah. So we're reaching the end of the podcast.
I'm available for children's parties, by the way. I just always try to point that out. I'm, Mr. Fun.
Nice. So I wanted to ask you about South American people, since you've been to Uruguay a couple of years ago. What do you think about us? How we work, the cultural fit with North American companies? How do you feel when you talk to Uruguayan and South American people?
No pressure.
Yeah, really, exactly.
Yeah, no pressure. You can see it through. It's okay.
Okay, I have to start by saying this. I got the most wonderful, warm reception in Uruguay. It was just absolutely delightful. We went out to eat. I'm an unabashed carnivore. Well, I'm actually a little abashed. I'm a little, sometimes I'm embarrassed about eating meat, but I like it. And Uruguay is paradise that way. We had wonderful chats and wonderful evenings out, and in the classes, people worked really hard, a lot of determination, a lot of drive, and that was evident. And I love the spirit of countries with smaller populations. That's always pretty cool because there's this kind of David against Goliath sort of thing. There's a great pride usually in smaller countries than in larger ones, and the pride is usually moderated to some degree. Here in Canada, we're living right next door to the United States, and it is the greatest country in the world. Just ask any American. They'll tell you right away. But I think most people live in their countries because they believe it's the best place for them to live. So my experience in Uruguay was absolutely wonderful. However, I want to point out that my experience wherever I go is typically wonderful because I'm invited there, for one thing, and people are very kind all around the world, and they're eager to show me their cultures and their food and their society. Oh, the thing about Uruguay that can't get out of my mind is the people.
Mate.
Was that?
Hey, mate. I have it right next to me. Yeah.
All the time, right? No, of course, it's similarities, cultural similarities elsewhere. But so Uruguay was distinct in the specifics, but everywhere I go, and there's a big selection bias involved there. It's because people want to do good work, And so they want to show me the good work that they're doing, and they want to share their problems when they have reason to believe that maybe it's not the best work that they could do. And wherever I go, that's always a wonderful thing. But I'd love to go back to Uruguay again. The spirit there was just really terrific, and ambitious and positive, and pretty capable, I'd have to say. There's really good work being done in the classes that I did, and the conference is fun too. Very seamlessly set up. That was great. It was what, Testing UI was the name of it?
Testing UI.
UI.
U
Testing
and
UI.
Y.
Yeah, UI. Yeah.
Nice. You're invited to come back whenever you want. We can go out for some beers and some meats if you want. We have a lot of barbecues.
Well, my inbox is open. So
Nice.
Very good. Michael, thank you so much. This was an absolute pleasure and an honor. Diego, thank you again for being a host today. It was just great to see you ask the question, and have a conversation with Michael. Definitely, we will do this again. Technology keeps advancing, and there will be new fun stuff to discuss. And we'll stay in touch, Michael.
I hope so. This has been a delight. Not as good as visiting Uruguay, but it'll have to do for the moment.